Hello art students. Today and in this video I'm going to continue explain perspective and go a little bit more into depth of understanding how it works. So the third lesson in the Russian academic drawing curriculum is drawing this structure, basically a rectangular prism made of 3 cubes stacked on top of each other. This is the eye level, this is the vanishing point. The structure gets built with that in mind. The second vanishing point doesn't fit in here, but it doesn't matter because we are already supposed to be understanding how if there is one vanishing point on one side of a rectangular structure, there is another on the other, it may not fit into our drawing. So I got a very similar box to a rectangular prism, which is about 3 cubes stacked. So which means it's the width of the box is about 1:3 proportion. So luckily Amazon has all kinds of boxes, and so saving one serves the purpose of teaching this lesson. As you can see, I put red pins for the eye level. What it means is that I want you to keep an eye on those red pins and the imaginary line that goes through them. Basically, if this is you and you come closer to the object and you put your hand right at your eyes and you extend it over here, you will see where it hits the box. That is your eye level, and it should represent where those pins are on the wall. And therefore, you keep an eye on your eye level, on that horizon line at all times. Once you get used to seeing your eye level, sensing it every time you look at other objects, it becomes easier. So we established that there, so now it's time to establish your eye level here. So I'm gonna approximately stake out my eye level, making sure it's parallel to the edges of my board here. So on your paper, you will be just simply drawing it with your pencil. I'm making it orange for the sake of clarity, so you don't mistake it with other lines. You don't have to do it unless it's extremely helpful to you. Unless all gray pencil lines are confusing, and making them colorful helps. All right, good enough. So how we check is that this distance continues and it looks parallel to the edge. That means it's the horizon line, it's parallel to the horizon. All right, the next step, we are going to position our box according to this diagram. I turned the box over there already at the angle that is extremely similar to this one. As you can see, there's less of this side visible and more of this side is visible, very similar to how we did our previous cube. So basically you can even just draw this on top of your other cube from the previous lesson, but it never hurts to repeat the same thing. So now we are going to find the bottom and the top, and compared to the horizon line, you see that this distance here and this distance here are about the same. So if they're about the same, that means that the distance from where our horizon vanishing point is going to be and our straight line for this prism is going to be needs to form a square. So let's drop a plumb line that is straight up and down, very lightly. We're still just getting used to everything. Okay, more or less straight, fine. Now we are going to stake out one cube above this. Let's say it's going to come up this high. One cube has to be before the horizon line, so let's say it will end right here. One cube will be going through the horizon line, and the other one will be below that. So now we can simply measure this distance here, drop it down here, and another one down here. So here we go. Here's your one cube, second cube, third cube. And now we have this distance from the horizon line down. And we can stake out the same distance over here. Let's guess it. Maybe it's like this. Is that good enough? Let's just simply measure it and see. So here we go. We have this long one. And we have this one, a bit shorter. Good. So this is our vanishing point. Now we are going to start connecting everything to it. So that means that our closest to us point and edge of the rectangular prism is right here. From here to here, we need to connect it with straight enough line. All right. From this point to here, we're connecting it with a straight enough line. From here to here, we're connecting it. No wavy lines. The board is slippery. What a slippery board. Okay. That's good. And then from here to here, same thing. Let's lower. There we go. So that gives us the inclination of each of the sides. Okay, I want to make this a bit better. All right, so now we can start working in the other direction, but actually we can also establish this other side. So as you can see over here, the other side is much shorter. It's strongly foreshortened. And basically you need to look at it and see just by how much is it foreshortened, what are the foreshortened proportions. So as you can see, this size here compared to here, it's almost like half. So basically if we divide this in half and we bring it down here, that's our measurement. Okay. And when you're drawing other objects that you're looking at, they might be buildings, they might be furniture, interior spaces. That's exactly how you look at it. When you're trying to figure out the angle of inclination here, you can do side measurement for this angle, and then you approximate this distance. If it looks about like half and half, great. If it looks like it's thirds, you measure less. If it looks like it's more than half, 3/4, you measure that. So now that means that we can bring this up straight plumb line again. And of course, by this time, it would be good if you could draw straight lines up and down. So how do we know this line is straight up and down? It needs to look parallel to all these edges. It needs to look like a 90 degree to the edge of your paper, to here. It needs to look 90 degree to here. And if you drew another line through here, it needs to be 90 degree. And through here, it needs to be 90 degree. So if you're struggling with seeing straightness, you can just check that. Look at it piece by piece. Is it 90 degree here? Great. 90 degree here? Great. You can also go ahead and measure this distance and see if it lines up everywhere. So you see how, at least in this diagram, we want this to be completely straight. Of course, if it was a tall building, much taller than us, there will be more perspective going up or down depending on our angle of observation. But don't overthink it right now. Just practice training your eye to see those lines continuing through space, going toward that vanishing point. So these exercises, the whole point of them is to train your eye. To train your eye to project these lines through space. Project them in your mind through space often. And that's how you see whether you drew something straight, correct, to linear perspective or not. All right, so now we've done that, we can move on to going in the other direction. In the other direction, the angle is less strong. This is more, this is less. So we can simply choose a milder angle. And if you have a box in front of you, you can do sight measurement. And you can line up your stick with the box edge. And let me see, I'll look in the camera. So here we go, line up with the box edge and transfer it into here. As long as you're holding it exactly flat and you have your hand stretched out, you can see whether you got it right or not. So that's how it works. Put in your first line as your first angle. Here we go. Here's my first line. So now we need to imagine it continue all the way through space. That's more or less straight. Same thing is going to happen here, but since this distance here is shorter than this distance here, that means that the same rate of dropping down is going to repeat according to this proportion. So for example, what I didn't explain in the other video is another way of getting that proportion and rate of descent correct. What you do is you can measure, let me get something shorter here. You can measure this distance here. And again, the tip goes to the top, finger stops right at this horizon line. This is what we're concerned with right now. We can also put our finger at here, but horizon line is a good, nice parallel line that doesn't change throughout the drawing. It's always at this place. So we'll measure this. We'll compare it to this distance, and we'll see that there is this extra distance here. That means this section of the rectangular prism is longer, greater distance by this much than this distance. So how about we just put a mark in here, right? So put a mark in here. Now we can measure this distance and compare its proportion to either this side or this side. This one is shorter, so let's see how it goes. 1, 2, 3. It's almost 3. Let's see how this one goes. 1, 2, 3. It's almost 4. Huh, that's interesting. That means that this distance over here is going to be also 1 to 4, almost a little over, or 1 to 3 on the top. I hope that all makes sense, because it makes sense to me. So that means is that, what it means is like, let's say we'll just transfer this line way over here. I have to reach over my camera to get to the side, so pardon me. All right. So here we go. We transferred that. So now we can take this, let's see, this one we already have, and compare it to this one. See, this is where it's the same, and we need it a bit shorter, right? So we probably need it somewhere in here. And if we are guessing correctly, we can now measure this difference, because this difference is this difference here. Now when we take this and divide it basically in 4, we end up with this distance to drop down to here, and this distance here will be proportional to this distance here in about the same way as this is proportional to here. See, by this mark. This mark here is this mark here, a bit lower. All right, so basically we figured out the rate, the same rate at which it goes down toward the eye level, and now we can connect it. So it doesn't matter how far this area is. It doesn't matter how far you put this. If you have no room on your paper, you're drawing something and it's cropped right here, it doesn't matter. The same way of figuring it out works further away or closer. And I'll show you what I mean. The reason that I'm extending it here all the way as close to this edge as possible is, again, to help you understand how to train your eye to see this, how to project all these lines in your mind. Once your eye is trained, you won't have any trouble seeing whether those lines are getting closer together at the same rate or not. All right, so we did that exercise. Let's establish this line here. So this edge of our rectangular prism is quite a bit longer than this one, but it's definitely shorter than this one. So here's our first cube right here. So we need to choose something shorter than the full height, because it's foreshortened, and our box should be here somewhere. Now that you put in your first guess, let's see, measure it, compare, looks good, maybe just a teensy bit longer. All right, so now this is definitely our line for this side of the box, and this is the other way. All right, so now we can proceed with dropping a plumb line and go all the way up to intersect with the other one. So this plumb line is easy to do because it's completely vertical. So again, it's 90 degrees to here. It's 90 degrees to the edge of your paper. It's 90 degrees to this one. If you're not sure, you can always check. Get this distance here. Check if it's the same, and so on. All right, good. So now we are getting our box figured out. So this is the edge of our box, but you can keep it light at this point. You don't need to make it too identified yet. Come on. I really have to reach high here for this angle. All right, so here we go. This is our edge of the box. You can now see how from the highest point, it's heading down to the left. It's heading a lot more down to the right. Same thing is going here, up toward the vanishing point, a lot more rapidly up toward the other vanishing point. So basically now we connect all of these points and draw the lines as if they're going toward those vanishing points. So here we already have that one, that vanishing point. Again, same rate, right? So you have this horizon line, you have this one, you have this one. You can pretty much successfully start guessing how it would go. Let's guess. Okay, here we guessed. And why did we guess this way? Because when I started moving in this direction, I have this distance, and this needs to be smaller, foreshortened, but so is this one. So this distance over here gets foreshortened, even though it's a horizon line and it's not directly part of our rectangular prism, it still is part of the structure and spatial relationships. So all of these proportions still can compare to the horizon line. Horizon line is not isolated. So now what we do is we take this distance here to the horizon line and compare it to this proportionally. Here we go. Well, we kind of did it before, so here's the distance. And now we can see how many times this will fit in the rest. 2, 3, and oh, it's kind of like a half almost, just a little bigger half. If we take this distance and compare it to this distance, that means this part will fit in the rest of it same way. 1, 2, 3, and a larger half. Looks about right. So that means that if we take this distance here, and this, if this entire line is going in the right direction, that this intersection will give us this distance. And we can take this and fit it in once. Oh, this is actually, here's once, twice, third time, and a half. Looks like this could be just a tad higher, which seems about right. But that just means that most of this line is actually going in the right direction. This intersection is good, and on over here, and this is good. So this is all good, and this is where it's going, toward that vanishing point. That's what we're concerned with. All right, let's get rid of this so it's not confusing us anymore. So now we've gotten this first cube constructed. We have the second, which will finish the third as well. So again, let's bring it down, focusing on the angle that fits nicely between here, here, and that horizon line. So we definitely know it's not going to go too steep too fast. Definitely no. It's definitely not going to go too close to a parallel, right? This distance here definitely has to be less than this distance to the horizon line. So let's guess first. How's that? I know it's too steep. It's going down too fast. I will make it less. But if you can't see that it's too steep, that's totally fine. You just continue through and just draw it and see how it goes. Correct yourself based on the measurements. All right, so, okay, this is my better guess. So what do we have now? We have this and this to compare, right? We can take this distance here, compare it to here. 1, 2, slightly less than 3, like 3/4 almost. That means that this distance here, 1, 2, 3, see, slightly less than 3, means we can probably raise this just a tad. And if we raised it just a tad, that means now it will be closer to 1, 2, and kind of like 3/4 in there, not quite third one. Okay, so here we go. This is a better one. And that means that we check this distance here. 1, 2, 3. Ah, you see, it went down too fast. So, correction. We raised it here a little bit, but you see a tiny little difference here makes a big difference there. So, let's raise it and see how this compares. 1, 2, oh, sorry. 1, 2, 3. Could be just a teeny bit higher because we need not full 3, but we need 2 3/4. 1, 2, and see, now it's more like 3/4. All right, so you see now we can correct this line, and you can leave the one that is wrong in place. Don't erase it right away. First, draw a more correct one. And see how it feels. Darn, my lines are wavy all over the place. Just see how it feels first compared to the incorrect one, and then erase the incorrect one and keep the correct one. So here we go. You see how the level of incline of this line is so mild. Compared to the horizontal, this is just barely changing its angle. All right, so now that we got that, we can solidify these lines. And with your pencils, you will be making them thicker, darker pencil lines. Somehow it's harder to do with these markers. All right, here we go. Here's my side, here's my other side. And now we can solidify this side to look like a side of a rectangle. So why are you erasing yourself? Okay. Don't erase yourself. Okay. And now we can solidify this side. That's, again, it's erasing itself. Okay. Okay. All right. That's better. Better than before. Now it's darker. Now we can see, okay, this is our rectangular prism. More or less straight. Okay. This is the edge. So much easier to do with pencils on paper. Now we can darken this corner. This whole line is the closest to us, so you will be darkening it a whole lot, making it darker and thicker. And at the end, you perfect everything. This is still a transitional stage. We're still working on everything, so it doesn't have to be super perfect just yet. And this one already looks pretty dark. That's fine. So what we didn't do is we didn't do the inside, right? So we're connecting this to here, and that is fairly easy. Too low. That's closer. Okay. And you can literally do a bunch of lines. See which ones just don't go there, because we can't use rulers here. And erase the ones you don't need. Leave the ones that work just fine. Okay. We want to see all of these lines so far. Okay. So here we go, we got this. We can do the other one. A little higher. That's pretty close. And by the way, just because we have this vanishing point visible here, doesn't mean you shouldn't play with checking the rate of the incline. And it's always good to do that, to understand and solidify it in your mind, the science, the mathematics behind it. Leonardo da Vinci said, learn the science first, learn from nature, but don't draw without knowing the science. All right, that's wobbly but good enough. So, what I meant is, let's say we will see how this proportionally compares to what it gives us, like basically the where we're going to put this in and how this is going to compare, right? So for example, we can compare, once this line is going away, if it's the same rate of incline. And it really doesn't matter if you're doing the back one, that belongs to the bottom plane. You can still see how it slices through these sides, and it does the same thing as this when we were drawing these two lines and we were just comparing the sides, because those proportions are everywhere. They're the same everywhere. So we can take this size, we can fit it in here, 1, and it's just a little short of 2, right? So now we can take this size, 1, see, it's just a little short of 2. That means this incline is doing what it's supposed to. While we can easily see it's going toward the vanishing point, we also know that it's good because the mathematics are working out just fine. All right, so this is the back of the box that we don't see. This is the other back of the box we don't see. Now let's draw, connect these corners with there. So again, let's guess. Maybe this is good enough. Looks good enough. Now let's compare our proportions. Let's see, we will compare how this line slices through here, for example, and how it fits into the rest of it until this one. No use going all the way to the horizon line because this one is closer, and this one we already know is going at the proper angle and rate. So let's compare this distance. 1. Here's 1. And again, it's just a little bit short of 2. Just note that. Compare this. 1. Here's 1. Oh, it's almost 2. I want to say a little short of 2, but not as little as that. That means this needs to be just a tad taller. So here's 1. Here's a go 1. And now it's a little short of 2. Okay, so that means this is definitely better. So this is definitely a better rate. And if we continue all the way, we can compare this. 1, 1. See, now it's below 2. So we were definitely off. What we were off here, this distance, ended up being way more over here. So we need to raise it way higher. So let's take this 1. Here's 1. Now it's too much. Okay. Lower. Now let's take 1. Here's 1. And now it's just a tad shorter than full 2, right? So here we go. Now we need to connect this with this. Okay, I hope you get my point by now. So now we can move on to connecting this one here, plumb line, with the vertical. By the way, it doesn't matter if you start with the bottom or with the top. Bottom seems to be easier, the angles are stronger, easier to kind of see these angles. But if it suits you better to start at the top, go ahead, start with the top one, it doesn't matter. All right, so again, this is a plumb line, it needs to be vertical. How you know it's vertical? If it's now, we have so many parallel lines here that we can see if it's parallel to all of them or not. Compare this distance, same, starting to veer off, more like that one, okay. Keeping this one, pushing this further, and this one, okay. So this is basically what you want to see here. Draw it vaguely, it's in the back. It's supposed to be the part of the prism you will not see unless it's a complete just structural prism with sticks. And in the box that is in front of us, we don't see that side. But now that side is constructed correctly. So that means we have this intersection now. We're moving to the next intersection. And we can connect it safely with this point here. We just need to see if it connects and goes down at the proper rate. If it doesn't, then we went off wrong somewhere. So what I'm seeing right now that it's too much this way. And it's a little too much. It's a little too much this way instead of this way, because right at the end here, this started to lean. And it needs to be more precise. All right. So now we can make sure that this one is also slightly straighter, not too much of a ball. That can happen. And that's where you perfect all of your lines once you're inching closer to the completion here. What worked good enough in the beginning gets perfected near the end. And now you can see how this is dropping now. Okay, and all it took was just that little bit. So now we need to make sure that this is coming toward here at about the same rate, right? So let's guess again. That's definitely too much. Like this. Something like this. All right. Now let's measure and check ourselves. Here we go. Here's this measurement. Here's this measurement. See the little tip is shaved off? Here's this measurement compared to here. 1, 2, 3, and a little tip again. So we'll take this one. 1, 2, and the little tip, but the tip seems to be a little bit bigger. So let's choose a slightly lower point. Just slightly lower. And compare that. Here we go. 1, 2, and the tip. Slightly lower. The tip is too big. Just again, I'm sizing up proportionally. I'm kind of getting the feel of how this distance compares to here, and that tip. 1, 1, 2. Now it's better. All right. So again, here's our proper rate of dropping, proper intersection. And that means that this continues through. Okay, continues through. And let's check the rate here. So this was 1, 1, 2, and a tip. And so this one should be, let's take this one. 1, 2, and a tip. I think it could be just a tad higher. Oh, my green marker doesn't want to cooperate very well. Okay, it's shorter. 1, 2, and a tip. We will call it good enough. So, inching closer to finishing the structure. This is our back. Back. This is our front. This is our front, front, and front. This is our front, front. That's a wobbly front. Now it's better. This is our front, and another one in the front. Okay, this is our back. Here we go. A bit wobbly, but at least then it's a nice thick line. All right, so now we have the whole top of the box that we don't see in the whole bottom constructed. All we have to do is construct the rest. And what I'm going to do is I'm going to stop explaining, just finish constructing. By now you should understand where I'm going with it. So I won't be measuring anymore. I'll just go by sight. Everything will now be connecting. If you went wrong somewhere, if something wasn't precise, these corners will not add up. They will not connect through the verticals. If you got all your angles of incline correct, they will all connect through the verticals, no problem. So this is going to be, I'm going to call this good enough, good enough. This is good enough because this corner has connected through the vertical. And this one here, yeah, it's pretty good here. So I'll take this, and I'll take this. And you see how, again, this one's already was very mild rate of incline. This is going to be even milder, by a bit, but milder. So I'm going to stake this out, and I'm going to basically bring it through, keeping it kind of close to this line, but getting closer to it just by a bit. Hopefully you see what I mean. Alrighty. So by now, you should have a pretty good understanding of how the math works, and your eye should be getting used to this inclines. Alright, that's enough finagling with that. Let's move on to the more important fish to fry. So we've constructed this structure. We can see everything. Everything is nice and straight. So where does it take us now? Now the main thing to remember is we are also dealing with the vertical planes that are going toward the vanishing point, as well as the horizontal ones. While the horizontal we're looking more down over here on, we're starting to look up at these ones. We are looking at the sides, the vertical planes, and we're seeing less of this, but as they move in that direction, we're seeing more. So while all the other sizes are getting less and foreshortened, for example, right, this, as it moves away, gets shorter and shorter and shorter. This, compared to here, is a lot shorter because it's a steeper angle as it goes toward the horizon. So these sizes are getting smaller and smaller. If we were to recreate exactly the same rectangular prism over here, it's going to be also between these two lines, and all of these lines are going to be part of these planes, vertical and horizontal. But the only size that is not shrinking is how much we see of this side. As you can see here, we see this much, and see here, it's opposite side, we're seeing more. And if we continue to move the box this way, or we say this is not anymore a rectangular prism, no longer made out of 3 cubes, but it's longer, and this direction it's longer and this one is definitely shorter, then this back side will open up even more. It's going away in this direction, the angle of observation becomes more open toward us. Here, all of these angles are becoming closer to this straight line with which we line up. So if you were imagining where you are standing in this diagram, you would be lining up with this. And you would be standing with your feet way below this level, because obviously this is your eye level. So this will continue to line up with the height, your height from the eyes down to your feet. So that means that if this box continued sliding this way, we'll see less and less of this side, less and less of this side. This side will be always less than that one. And by the time the box reached this point, at least with this side, we would no longer see the side that would line up completely with this line. We'll only see this line, and we would see something more like, just a quick, for the sake of the explanation example, we would see it looking more like this. Sorry, no. Something like that, to where the back side will line up completely with that line. I didn't want to mess up my perspective lines here, so that's why I had to make them dashed lines through here. But I hope you understand what I mean. So here we go. Messy, but that's your diagram. Not this one's, formal lines, those ones. So, if this box continues to move, we will end up not seeing that one and start to see this side again. At one point, we will see both of those sides on the inside, fitting inside, much like what we were studying with the cube. I'll show you in the book. Like this one. That is where that line comes right through the center of the cube. That is this one. This one, once this line comes right through the center of your cube, rectangular prism, what have you, all of this starts going in this direction. All of those sides go toward that vanishing point. Alrighty. So what does this mean? Getting a very long way to the final point. What does that all mean? It means that knowing how this works, you can recreate any structure that is taller than your eye level, interior of the room, buildings outside, and so on. Once you know what is parallel to each other, just like I explained in the other video, you can recreate any other object that is parallel to your original structure. So imagine if what you were doing is drawing a street scene where another building was on this side of where you're standing. So you're looking at this one more, but this one is slightly closer. So again, you would be bringing everything from that vanishing point. Let's say it was on the same, it lined up with this building. So plumb line, let's say it was the same height as this building. So that means it would come to the vanishing point. This would be the side of this building. This angle of incline would be a little bit less because this now is closer to this line. So instead of having the same angle here, we will have a milder angle. For the sake of explaining, I'll do it like this. Okay, that's it. This marker is going out of business, new one coming in. Okay. It will be this. The same thing happens. Now they're all going toward another vanishing point. This angle of incline here is mild. This angle of incline here will be milder still because the vanishing point here is further away than here. So you see how the closer the vanishing point to the side of what you're drawing, the more this distance shrinks, right? So here the vanishing point is at about equal distance here. That height of the building, now that box became a building, to this distance, but here it's a lot more narrow. And therefore, we're seeing less of this side of the box or building, whatever you're drawing, but you're seeing more of that one. Here, you're going to be seeing slightly less of that one compared to here. But this vanishing point, therefore, is slightly closer because the angle of incline is stronger. So it's that vanishing point, even though it doesn't fit in here, it still is closer to us than this vanishing point. This vanishing point is going to be way far away on there. All right, so we can say like, all right, if these buildings are about the same size, then we will take this distance and we will make it just a little bit wider because we've seen more of this, right? More of this side of the building. All right, we'll bring this up just like that. That's that side of the building. Fine, I'm going really sketchy now. Let's say that this building was no longer just the 3 cubes stacked on top of each other. It was a long, tall building. It's going to go further back. It's going to have this much of a distance. How do I know it's going further back? Even though I'm choosing this distance, and it's actually shorter than that, because this turn is a lot stronger. And even though this seems closer, it actually ends up being longer. Once I complete this, the rate of foreshortening is a lot greater here. So once I complete that, you can now start seeing it that there's no way this is a cube. No way. All right, super sketchy, but here we are. So now if this connects to here, then we got all of our levels good. Here we are. So basically, this is your interior of the building. How much of it you need depends, but for studying of the perspective, this is what you should be experimenting with. All right, so you can see that this is definitely looking more like it's a rectangle, on much longer here than here. Let's say that this building, we can put another building next to it, or we can extend this side of the building. Let's just put another building next to it. Here we go. And another building will continue. Let's bring the plumb line up here. Here's your another building. Here it's a side that we see. And let's say that we wanted to put like windows or something in there. By the way, right here, if there's an alley or a street in between the buildings, depending on your proportions, all of this will still be going and doing exactly the same thing as all these other lines. Exactly the same thing. They are not going to be going in any other directions as long as this building is parallel to this one, which usually is what happens on the streets. They usually build all buildings parallel to each other. It's just easy to plan out the streets. If the buildings are not parallel to each other, it becomes very obvious. And then obviously you figure out how, to which degree they're not parallel, and how do you change these angles of incline and find another vanishing point for the building that isn't parallel. I'll explain it on another object in between this, in this street scene. So now, of course, this goes in this direction as well. So we are seeing this building here. Cooperate. Come on. There we go. We are seeing this building come from behind it, just like that. We're seeing it go behind this building, and we're seeing it go in this direction. Let's say that this already obviously doesn't look like a 3 cube stacked, it looks more rectangular. So what we are not seeing is all the back and inside lines in there, all sides. They're all going in that same direction, same angle of incline. By the way, this one's so close to this that if I projected it, you can see how this becomes easy to guess. This will be the back. This will be the back, what we're not seeing. That means this 2 intersects here, and it looks pretty good. All right. So the back of this building is over here, and it intersects with this, so also lines up. Okay, so we lined up all these buildings. Now we can, let me make it dashed so it's definitely not confused. All right, so if we added windows, by the way, you can add as many buildings to the street scene as you want. Let's just, for fun, throw more straight lines in. Let's say that those buildings are now so close together that all we see is only a little bit of their edges. All right. And so that means that this comes up and hides, and like right in here, and this comes up and hides, so it's something like this. All right. So let's say that we'll do the same thing over here. We'll just add a few more buildings. And so on. Never mind about the details. See how it's starting to look like a proto street scene. So windows, let's add windows. Let's say that we will, just for the sake of this diagram, we already have these lines and we will simply utilize them. So let's say that on the front here we'll utilize this line because we can say that all of our doors on this side are going to line up with that anyways. And on the other side we're going to have perhaps windows. So if we had doors, this would be our center. Remember from the other video how I showed you to find the center for shortening and so on. Now, once you're trained to see that, you will know that this looks about right for the center. So let's say there were two doors. Well, let's keep it simpler. One door. That means that if there was a one rectangular door, big white one, we can put it right here through the middle. Again, centered, and we can put it right here through the middle. This door becomes centered on the center of the building. No questions about it. Because we know how to use foreshortening and find the center. So we can stake out this door. We can go ahead and add, let's say we will add a door through the middle of this and the rest will fill with windows. The center of this side is going to be about here, accommodating that foreshortening, right? And that is if this is the edge of our building. This is the other building. This is the one in front of it. So then, same height. Doors are usually the same height. So we're going to stake out the door here according to the rules of foreshortening and perspective. Here's your door. And let's put a couple of windows. Windows, interesting part is, usually line up with top of the doors, usually, not always, but they come shorter. So imagine if you had a person walk through this door. Person would probably be somewhere in here, right? Somewhere, here's the head, here's the feet. So, person would be walking through this door and through the center, as it happened. And that means that where would it be comfortable for the person to have a window? Normal window height is about like below the chest, right? Half and half. Half of the person is the crotch and the legs. The other is the torso and the head. So that means the torso line right here. And that means that the windows are probably going to be coming to this level here. Again, if we just project this according to the same perspective all throughout this, heading for this vanishing point, we can put a window in here. Let's keep it simple, just one window. And we can put another window right here. And they will be correct with the human proportions. That also means that since this line came right here, this is the height of your windows, then we can go ahead and bring this line with this perspective, according to the rules of perspective, in this direction, heading for this vanishing point. Okay, well, I hope you know what I mean. Slightly lower. But nonetheless, it connects to here, right? It just has to. Windows are always on the same height. That means on this side, and this is your door top and window top. It points right here with our perspective lines. going in the same rate. This is going to be the space for your windows here. This is about the center, maybe a little slightly over. That means we can fit, let's fit 2 windows in here. Here we go. Here's 2 windows here. And on the other side, we're gonna fit 2 more windows. Should probably space them better. You get the point by now. Here are your windows that fit according to all the rules of perspective and even proportions, if we imagine a human being on this, of this height. So, likewise, we can fit all the windows over here and do it in a very sketchy way. If you don't want a door, you don't do a door. If you want a door, you do a door. Here's a window, here's a door, here's a bunch of windows. And so on, it will continue all throughout this diagram. Here are going to be your windows, here's going to be your door. Here are going to be your windows. By now they get so close together, it's hard to distinguish them. All right, that means that we can also do the same thing all the way up. Exactly the same rules. So if the door came up to this height, let's go and calculate from here to here. So this is our geometry. That means over here, this is where, nearly on the eye level, is where your any other doors are going to be. See how it works? So let's say we had balconies. That's fine. So the balcony, like, for example, will come out somewhere over here, somewhere over here. It will go in this direction. Over here, let's say it extended just a little bit. Let's say it also goes for that vanishing point. So this will be the side of the building. This will be the extension for the balcony. This is the side of the balcony, and then the building continues, right? Now it's getting to be too tedious here, but hopefully you see my point. Now this becomes your balcony. The railings of the balcony are right here. But remember our door height? That means that if the door was lining up with that, we can line it up with the center, which means it will also line up with that door as well. So that means that the balcony door also lines up with the width of the balcony. That can happen. And the other side, this will be your balcony door. This will be the floor of the balcony. And how high do railings come up? So again, the railing needs to be safe. If this is the person, this is the crotch, the railing needs to be a little bit higher, kind of the elbow length usually. So you could like lean on it with your hands. So we can see that that person is standing further away, right? So that means the perspective is still working. That means that if this is the elbow height for the person, and this is the measurement from the person's feet to the elbow, and this is to the head, let's get the rate, 1, 1, 2. So we need to divide it in 3. So basically, over here, whatever to get the distance over here, we need to have the height of the person which almost lines up with this line. So about here. This is about the head of the person. And then the person is divided in 3 parts. 1, 2, 3. A little lower than that. And therefore, we'll do the same thing here, because then that means over here, if we were building a railing, like let's say on the street, it would come up to here. If we're building a railing here, we need to figure out the same proportions, right? And the proportions is 1, 2, 3. Let's take this door, divide it into 3 parts. 1, 2, 3. So that means that the railing comes up almost to here somewhere. Okay. So again, in this direction, it's going to go with the rate of this angle, right? Here it's going to go toward this vanishing point. And this will be your railing. And of course it will go in this direction as well and attach where the door is. And whatever the designs of the railing are, there they are. Right? So that's your door according to this rules. According to this diagram, the rules of perspective. So let me change to a different color so you can see better. Here's the railing. Here's the vertical part of the railing. Here's the bottom. And here's the door. So, still seeing a little bit into it because our eye level is here, but starting to get less steep and more close to our eye level. So, we can continue adding windows and everything. I don't want to take the time now. It's already been a long lesson. But look at this, for example. So if this is the person, then we can make this into a street. This will be the sidewalk. Means the sidewalk will come out here. It will start going in this direction. The angle will start getting steeper. Perhaps not quite this steep, but steeper, kind of like this. Same rate, you got to hit that same rate. If you want to still continue measuring, you certainly can. So here we go, here's your sidewalk. Sidewalk has thickness, then there is the street, right? You can add thickness, except here it will pretty much blend with this line because it's just such a small distance, it becomes negligible. All right, but right here your sidewalk has that thickness. Right here it will have that thickness. This being the edge of it, if it lines up with the building. And the same thing obviously will happen on the other side. So you can also bring the sidewalk if it's lining up with this edge of the building and with this street here. If it all lines up, same thing happens here. Now, so if for some reason you're doing a street scene like this that captures a very wide angle, you can see how what is happening is that these lines, these sides, these planes, vertical planes are going in this direction, these are going in this direction, but if we continue them through here, they're gonna intersect like this, right? They're gonna have this angle. In reality, it gets smoothed out. In reality, this becomes a curvature. So if you are drawing, let's say, someone actually crossing the street and they are going through from this sidewalk and they're going from here over to here, your lines are gonna gently merge and the zebra stripes are gonna be painted this way. The zebra stripes are all gonna go to the vanishing point nonetheless. Now I'm just gonna guess. Here they're gonna be, this one will be completely vertical, and here they're gonna start getting further away. Here are your zebra stripes. This is what will happen. And then this could have been lower to accommodate the same proportion. I didn't quite hit it right. Now that I'm standing back and looking at it. But again, I'm doing just diagrams, not true to some reality. But even with diagrams, you can guess a lot and make it close to looking like reality. So here we go. So this is how it works. Same thing obviously with all the windows over here. Anything else, therefore cars, people, anybody who walks through. This is about the center of your street. Again, we are figuring out this distance and this distance. Since this is where it straight lines up with us, with you, the viewer, artist, this will be slightly more and this will be slightly less. So that's why this distance is slightly more than this, from the edge of the sidewalk to the other sidewalk. And therefore, this is how it works. And you can continue it right through from your vanishing point. You can make it straight. Can make it slightly curved, depending on the feel you want to get. Are all streets exactly level? Not always, but the conversation and lesson about the inclined planes will be in another video. Now, let me know in the comments if you have any questions, if I didn't explain something clearly. Don't forget to like this video, share it with someone, support me on Patreon, and visit my website to buy a painting. Until next time.